Okay, problem number 30. You're shown a picture of a crayon, and the crayon is being measured using a ruler. Looks like a centimeter ruler, and you're asked a few questions. First question, A, says, what is the length of the given crayon in centimeters? Seems like a simple enough question. And you might look at this and say, okay, it's between 4 and 5. It looks like 4.5 centimeters. But be careful. Is it 4.5? Is it 4.50? 4.500? You know, how many digits do you include in your measurement? So, if you want to know more about how to record measurements properly, I'm going to point you to lecture 5. That explains how many digits to include. And you have to look at the measuring device pretty carefully. Now, looking at this ruler, everybody is going to agree that it's between 4 and 5, and it looks like it's around 4.5, but you have to look pretty closely. So let's zoom in a little bit, you know, on the end of the ruler. Okay, it looks like it's about 4.5, but maybe it's between 4.5 and 4.6. It seems like that way to me. So I want to get a little bit finer, pencil, and let's, just kind of, so there's 4.5, there's 4.6, and it looks to me like it's, closer to 4.5, but it's a little bit more than 4.5. And anytime you take a measurement, so we all agree it's a 4.5 something, okay? The tick marks tell us that it's 4.5 something, and if anybody looks at this carefully enough, they're going to agree that it's 4.5 something. But where we might differ a little bit is, how far between 4.5 and 4.6 is it? And so you have to estimate, you always estimate the last digit in a measurement. So here, this last one right here, I'm going to, color that pink. So I should have colored that part right there. This is always the estimated digit. The last digit in a measurement is estimated. And it looks to me, I'm making the measurement, so I'm going to say it looks like 4.53. If you were making the measurement, you might say 4.54. Somebody else might say 4.52. But it's very unlikely, looking over here, that anyone would say 4.59. Okay, it's pretty close to 4.5. Okay, so we would all differ a little bit in the estimated position. And now that we have the measurement recorded properly, we can go on to the next question. Okay, so question B. So what's the next one? B asks, how many significant figures does this value contain? Well, once you have the measurement recorded properly, it's easy to count sig figs. Oh, I forgot something in the measurement. Never do this. You always need the units. Okay, the length of the crayon is 4.53 centimeters. Jeez, your instructor's doing that, man. 4.53 centimeters. Okay, so that's the measurement. Now, once you have the measurement, you can count sig figs. Okay, it's basically looking at your measurement right here. You're looking at all the numbers. Okay, so starting from left to right, here's the first number in the measurement, and here's the last number in the measurement. So this is 1, 2, 3 sig fig measurements. Okay, that's how you count sig figs. When you're reading a measurement, you read it from left to right. Here's the first number, and here's the last number, and that spans 3 positions. 1, 2, 3. This is a 3 sig fig measurement. 3 sig figs. And if you want to know more about sig figs, again, go back and watch lecture 5. I talk all about this, okay, more than you probably would like to know. The last question in number 30 is C. C asks you to convert this value to meters and write the answer in scientific notation. Okay, to convert centimeters to meters, you need to know the relation between centimeters and meters, and 1 centimeter is the same thing as 100th of a meter, or 0.01 meters. You can find this in the textbook. I believe it's the prefixes are listed in table 1.2. Okay, so I'll write this table 1.2. Okay, so 1 centimeter is 100th of a meter. Another way to write the relation between centimeters and meters, and one that I kind of like a little bit more, is if 1 centimeter is 100th of a meter, it takes 100 centimeters to equal 1 meter. Now both of these tell you the relation between centimeters and meters, and either one can be used to convert centimeters to meters. Okay, so the way we do this is we take our measurement of the crayon. So we start with 4.53 centimeters, and then we use either of these relations to build a conversion factor. And I like this one on the bottom, so I'm going to use this one. So we're trying to go from centimeters to meters, and so we turn this relation into a conversion factor. Remember, that's that special type of fraction. The units that you're trying to get rid of, you put on the bottom. So the 100 centimeter part, the left side goes on the bottom because we're trying to get rid of centimeters, and the right side goes on the top because we're converting to meters. And you see, when you have it like that, you can see the centimeter units canceling, and you're left with the meter units. And so you can see your units work out to be meters. Anytime you do a calculation involving measurements, you always calculate the units separately. So centimeters times meters over centimeters, you're left with meters. These two cancel, and then you do the numbers separately. 4.53 times 1 over 100, and that would be, let's see, 0.0453 meters. Okay, so when you divide by 100, that decimal point is going to go to the left 2 places. So, 0.0453 meters, and that's the length in meters. Okay, I'm going to put a check here. Check. By the way, if you wanted to use the other one right there, use the first relation to go from centimeters to meters, you could do that too, and it would be done the very same way. You would take your initial measurement, 4.53 centimeters, and then use this one to build a conversion factor. You're getting rid of centimeters, so you put 1 centimeters on the bottom. So 1 centimeters on the bottom, and then you're converting to meters, so you put the 0.01 meters on the top. And do the calculation again. Again, you handle your units separately. Centimeters times meters divided by centimeters. Centimeters cancels, and you're left with meter. Okay, that's your units, and now you do the numbers. 4.53 times 0.01 divided by 1. The dividing by 1 doesn't do anything. So 4.53 times 0.01. You multiply by 0.01, you're moving the decimal point over to the left 2 places, and again you get 0.0453 meters. And there you go. So that was problem number 30. If you look at problem number 29, it's very similar. This time you're talking about temperature measurements, and you're asked for the measurement of the temperature. Make sure you're reading between the lines. Okay, it's read between the lines. Is it 70? This is 75, 76, 77. It's between 76 and 77. So 76 point what? So you make the measurement. You estimate 76 point what? Don't just say 76 or 77. You always estimate one more position between the lines. So 76 point what? And then don't forget your units. Okay, it's 76 point whatever degrees Fahrenheit. And then, do the other ones too. The last one has you convert it to Celsius. You have to look up the equation for that.